So let's take inventory here. We already know how to multiply these ones together. -1 times any one, any negative times any positive. And now the next thing to tackle would be to, what about when these guys start multiplying amongst themselves? Negative times negative. That we haven't done before, so now we tackle this. What if you take this -1 and multiply by itself? Well, let's do that. -1 times -1. That would be something where we need another brilliant idea. Amazing. The brilliant idea is always, where should you start? Nobody tells you these things. Well, of course, you watch me do it. I saw somebody else do it. And eventually you see different people doing it, and then you start to chef the stuff yourself. You start to invent it yourself. And that's a beautiful thing. You'll feel really, really good when you start coming up with your own proofs. Right now, you might be a beginner. It's okay. Just watch how other people have done it, and you'll start coming up with your own brilliant ideas in no time. Alright, let's do it here. Talk is cheap. So here, of course, this is true. I know this is true because they're additive inverses. Okay, any number plus its additive killer will give you 0. I could slap a -1 plus 1. I could slap a -1 on this side, so long as I do same thing on that side. That's called multiplying both sides by -1. Fancy name, Cancellation Law of Multiplication. I could take this and distribute it in there, and that would give me -1. Whoa. Times -1 plus 1 times -1, and that of course would be equal to 0. On the left hand side I use the distributive law. On the right hand side I use the OMT, 0 multiplication theorem. 0 times -1, 0. I told you. Wait, there's more. -1 plus no. Should wait, let's undo that. Let's undo that. Alright, -1 times -1 plus, alright, 1. 1 times -1. How do we multiply by 1? It's so easy. You don't do anything. It's the do nothing element. It's the multiplicative identity. It says nothing happens when you multiply -1. Sorry, when you multiply by 1. So I multiplied -1 times 1 and nothing happened. Now what I'd like to do is add 1 to both sides here so I can get rid of this, and I'll have this piece isolated. So I'll say something like this: -1 times -1 plus -1 is equal to 0. I'll go to the left side and I'll add a 1 killer. I'll go to the right side and I'll add a -1 killer. I can do that by Cancellation Law of Addition, which says I can add anything to both sides, which I did. Whew, it's awesome, huh? Wait. I can slide the parentheses over and I can have -1 times -1, whoa, times -1 plus -1 plus 1, and that's equal to 0 plus 1. So I slide the parentheses over. That's called Associative Law of Addition. Of course I did that because I know these can kill each other, so I'll have -1 times -1 plus 0 is equal to 0 plus positive 1. Additive inverses. That's these guys right here. They kill each other and give you additive inverse. Starbucks sells coffee. Ford sells cars. Mathematicians, what do we sell? Perfection, beauty, and creativity in reasoning like you've never seen before. You're wired to love creative reasoning. You're wired to love to understand. You can't help it. It's just like you're wired to love chocolate and you're wired to love sunshine. It's the same thing. So how do you add 0? Well, it's so easy to add 0. You don't do anything when you add 0. It's just -1 times -1, and that of course is positive 1. Additive identity, yippee-ki-yay. Proof with perfect, flawless reasoning, every single step justified, broken down like you've never seen it before. It's amazing. I love it. A third grade fact that nobody ever proves. Just a few steps. What it boils down to is, do you know your rules, what you can and can't do? Alright, we'll leave it there. Now come back we know how to multiply any one of these negatives times any positive, no problem. And even -1 times -1, that's the, oh yeah, I forgot to tell you guys, that's the NoTNoT theorem. So we're going to collect all these steps. All these steps are going to be collected into one, and it's called the NoTNoT theorem, which represents -1 times -1 theorem. This tells you how to multiply -1 times -1. It says -1 times -1 is equal to +1. That's the NoTNoT theorem. Super famous. Actually, it's not famous. Well, the name's not famous. I made the name up. But the ideas are timeless. Alright, so let's take inventory of what we know so far. Let's take inventory. So now we know how to multiply any -1 times -1. That's the NoTNoT theorem. We know how to multiply by zeros. We already knew how to multiply positives. We already know how to multiply any negative times any positive. The only thing we're left to do here is how do you multiply these numbers amongst themselves? Any generic negative times any generic negative, not just -1. So for example, these two. That takes us to this idea, a negative number times some other negative number. Let's see how that goes. So for example, -2 times -5. Alright, let's see how that goes. We're going to use a similar idea that we had before. Let me undo that little note here. I'm going to use a different color. That's good. So -2 times -5, that's our given. I put G for given. I could use that trick I used earlier where I unglue the negativeness from it and I say, you know what, that right there can be unglued to just be -1 times 2. This one right here can be unglued to just be something like this. And that would be called the minus theorem. The minus theorem says you can unglue the negativeness, or said differently, between any number and the negative you can squeeze a 1 in there. Okay? Alright, and then I'm going to move these parentheses around. I want to shuffle them around because I already know how to multiply -1 times -1. If I can just put these two together, I'll be in business. So, but I can't just jump the parentheses. There's no law or axiom that says you just jump the parentheses. But there is one that says that if you have times, all these is times, you can regroup them any way you like. So I can regroup them like this. That would be called Associative Law of Multiplication. And then there's another one that says I can swap these two. So that would be -1 times -1 times 2 times 5. And that's called Commutativity Law of Multiplication. That says I can commute. And then there's another one that says I can regroup these. And so I regroup them like this, so. And of course, if that one's famous, it's called Associative Law of Multiplication. Duh. And now, this is a piece of cake because we just got done doing this like 5 minutes ago. We learned how to multiply -1 times -1. That's equal to 1 by the NoTNoT theorem, -1 times -1 theorem. And so this becomes 2 times 5 by multiplicative identity, which says nothing happens when you multiply by 1, you get the same thing. And of course, if you wanted to, if these were variables, that's where you would stop. But if they're actual natural numbers, you can go one step further and say, well, by times table, that's equal to 10. And so this tells you exactly how to multiply a negative number, any negative number, times any other negative. In the end of it, all you do is squeeze out the negativeness from it and use the NoTNoT theorem. And we can collapse all these steps into one theorem, package it into one theorem, and that one theorem will be called the negative times negative theorem, which says that any negative number times any other negative number will give you the positive version of them. Like that. So beautiful. Perfection in reasoning like you've never seen. The Bugatti of algebra classes. See? What we did today. Today we learned to multiply by negative numbers. First we learned that any -1 times any number will just be the additive inverse of the number. Or said differently, if you read it that way, it says that between the negative and the number you can always squeeze a 1 in there. Okay? The negative times positive theorem says any negative number times a positive version of it would be the negative version of it. Just like this. The NoTNoT exclusively to multiply -1 times -1. Exclusively. And that's the key to proving the next one, any negative times any negative, because all you do is squeeze out the negativeness from them using the minus theorem and then use the NoTNoT. And that gives you a good recipe for multiplying any negative number times any negative number. You should make sure that you own these theorems, that you can prove them on your own. And once you own them, you can use them anytime. You can just quote them. One line has got the entire package of all the steps into it. It's a beautiful thing. I'll see you guys here next time. Peace.